right, so how can we graph exponential functions? Well, doing this is going to rely heavily on the transformations that we talked about a while back. Right, I'm going to start, like I say I want to graph this guy here, f of x equals 3x plus 1. Well, I know what g of x equals 3 to the x looks like. Right, this is going to start here. Right, so that's its y-intercept. It kind of drops off over here on the left, and it increases super fast over here on the right. Now, when you're graphing these things, I always have students run into trouble with on quizzes and tests. Don't forget to include that asymptote. Your graph is not correct without it. All right, so now I want to graph the function I actually wanted, f of x equals 3 to the x plus 1. And you remember what adding 1 to the function does? That is a vertical shift. It's going to shift the graph up 1 unit. So the way I like to do that with these graphs, I kind of focus on a key point. I'm going to look at this y-intercept here, and I'm thinking about what that point does. That one goes from 0, 1 to 0, 2. Other than that, the shape of the graph stays the same. Right? So I'm just going to have this same dropping off here, and this same super fast pickup here. And now look at the asymptote. Right? Look at the asymptote. It moved up as well. Right? We did a vertical shift. Excuse me, I get vertical and horizontal. We did a horizontal shift, right, because we moved it up. When we do a horizontal shift, that horizontal asymptote gets moved along as well. All right, so how about this thing? Right, I told you in the last lecture we were going to think about what happens when you have a fractional, well, not fractional base, but when you have a base that's between 0 and 1, like 1/2 is. I'm going to start this off the same way. I'm going to say, look, g of x equals 2 to the x. Right? That looks like this. And don't forget to get the asymptote in there. Right? Now, here's how I want you to think of that 1/2. Right? I want you to think of that 1/2 as 2 to the negative first. That means f of x is 2 to the negative first to the x power, which is 2 to the negative x. Now I can see what's going to happen here again, thinking about transformations. Right? When I put a negative in front of the x variable, that is a reflection across the y-axis. Right? So my intercept here, the point that's actually on the y-axis, that stays the same. But the other two parts get reversed. So now the drop-off part here is going to go from the left side over to the right side. And this really fast going off into space part is going to shift from the right side over to the left. There was no translation here, right? So the asymptote stays exactly where it was. Okay, so that's first, yet another application of these transformations we've talked about. And second, this is what happens when you have a base that's between 0 and 1. All right, so I've got one more example here, right? And you can go ahead and try this one on your own if you like. Go ahead and pause the presentation, see if you can work through this, then come back and we'll do it together. All right, so I'm going to use the same method here, right? I'm going to let g of x equal 4 to the x. Then my h of x, I'm going to use a different letter each time. This will be 4 to the x plus 1. It's going to be a side-to-side translation, vertical translation. And then finally, we will get to f of x equals negative 4 to the x plus 1. All right, so 4 to the x, this is just your standard exponential equation. Sorry, my art skills are a little hit or miss. Right, that's a standard exponential equation. X plus 1, that's going to shift this 1 unit to the left. Right, so And again, I'm going to kind of track on this intercept here. That's going to go from 0, 1 to -1, 1. It's going to move 1 unit to the left. Everything else, the general shape of the graph stays the same. And we didn't shift, we didn't translate it all. Excuse me, there wasn't a horizontal shift, so the horizontal asymptote stays where it was. And then finally, we're going to do this minus sign, a minus sign in front of the function that reflects it across the x-axis. So again, kind of focusing on this point here, right? It goes from -1, +1 to -1, -1, comes down here, right? And the rest of the graph, whoops, sorry, my finger slipped, looks like this. Again, that stays, the asymptote stays right where it was, right? Forgot my arrows here. There we go. Okay, so that's my graph, right? That's what the graph of -4 to the x plus 1 power is going to look like. All right, so hopefully you see here, graphing exponential functions is really all about those transformations. All right, now in the next lecture, we're going to do kind of the obvious thing. Where do we always end up in an algebra class, right? Sooner or later, we always end up talking about equations. So in the next lecture, we're going to think about how we can solve equations that have these exponential functions or expressions in them.